Yes, class, is this audible?
Yes, ma'am.
Yes, so Zaid, Razan, Imad, Anushka, Alan, Ahmed, Asta. I think all of you were present yesterday.
Yes, ma'am.
Okay. C class, yesterday we had stopped at this point where we had seen this formula, denser to rarer refracting surface. So both the formulas we have seen. One numerical, let us do just one numerical so that we can see the usage of this formula. One numerical, let's see it. So this says an object is at a distance of 20 centimeters from a spherical refracting surface of radius of curvature 10 centimeters, right? You have to find out the image distance. Calculate image distance, and refractive index of glass is given as 1.5. See, it's like same thing, the way we had seen the derivation. No, I hope you all have revised. Any doubts you have, please let me know. So this is the glass part where this is 1.5. Even if you do not draw these lines, then it's fine. Just spherical part should be drawn. So 1.5 is it? Radius of curvature. Let's say this is 10 centimeter. This is radius of curvature for this curved part. What else is given? Yes, object distance. Object is, let's say, kept here 20 centimeters. So object will be positive or negative. What about the sign conventions? Object distance is taken positive or negative?
Ma'am, negative.
Negative, yes, because see, it is against the direction of incident light. Incident light always falls towards the mirror. Now this is opposite, or you can also remember this in the manner, anything that is kept in front of the mirror, anything that is kept in front of the lens or in front of the refracting surface, that you take it as negative. This is for just remembrance. Otherwise, whatever you have studied, that against direction of incident light, above principal axis, all the sign conventions that are valid. So see, the surrounding is air, refractive index will be here, air. See what all things we have. N1 is equal to 1, air. N2 is given to you 1.5 refractive index of glass. Object distance is also given minus 20 centimeters. Radius of curvature here will be positive, it's on the opposite side. So that will be plus 10 centimeter. Image distance we have to find out. So formula based question. So yesterday only we had seen, so this becomes which case? From air to the glass it is going. So from rarer to denser. It means N1 by minus U plus N2 by V is equal to N2 minus N1 by R. Now keep in all the values 1 by minus 20. Right? Why minus 20? Because 1 minus, this minus is of the formula. And minus 20 we are keeping it because of the sign convention. That I was saying when we ended the class, that keep the sign conventions. Just one place you do not have to keep the sign conventions is optical instruments. That when we'll do the next weekend, I'll tell you. So this becomes 1.5, image distance unknown. Again, 1.5 minus 1, radius of curvature positive 10. So 1 by 20 plus 1.5 by V is equal to 0.5 by 10. So this we can write it as 1 by 20 and we can subtract this. So let's bring it on the opposite side. So 1.5 by V is equal to, this will become 0.5 by 10 minus 1 by 20. To multiply this term by 2, when you take the LCM will be 20. So 0.5 into 2, that will be 1 minus 1. So 0.5 into 2 will give you 1. So it means what is this entire term? 1.5 V is equal to 0 by 20. Right, 0.5 into 2 gives you 1. 1 minus 1 is 0. Now C class, it means 1.5 by V is 0. So V will be what? V will just take the reciprocal. V by 1.5 will be 1 by 0. It means your V is simply infinite. This is the answer to this question. Okay, note down this, then we'll start with a new topic.
Ma'am, can you scroll up? Yes, ma'am. You can scroll down.
Someone texted on the group as well, no? Alan, it was you, I think. Alan? Or who was it? Someone has texted, no? That the class didn't start. Today's class started 15 minutes late. I don't know why the meeting was not getting started. So I think it was Alan's message. Is Alan there in the class today? Yes, yes. Yes, Alan, Jason, are you there in the class? Respond in the chat column if there. Done till here. See,
Yes, ma'am.
okay, now a very important topic is the lens maker formula. This is after the topic that we had TIR, lens maker formula is also one of the very important topics. Zaid, how was your exam?
It was pretty well.
It was good? Okay. Do show me your question papers, Zaid. Okay, and if any question you're having difficulty in it, text me, I'll share the solution with you then.
Okay.
Okay, and whenever you all receive your scores, please keep on updating. I think from this batch, Astha's score I know. Some students I remember, but some of you have not shared your half yearly and all those midterm scores. So keep on sharing because revision classes will be planned accordingly, and whatever weaker areas you have accordingly, we'll have all this. So that's why I was asking. Okay, yes, now coming to lens. So mirrors was the first part in which when we cut the spherical part, we painted one side, we obtained mirrors because it performed the function of reflection. Then if we just kept the mirror, the spherical refracting part, and we didn't paint it, that became the spherical refracting surface. But if I combine two spherical refracting surfaces, that becomes lens. So this is the third and the last new part. Now you just have topics related to this only. Prism is there, prism we'll see later on. So when you combine two convex surfaces facing each other, like this, you get a convex lens. So we call this convex lens only, and whenever we'll be using the term convex, or whenever I'll say convex lens, you will draw this only. This should come into your mind. But specifically, this is known as biconvex lens because both sides are there, right? Biconvex lens. And this you can also say double convex lens, biconvex lens, but usually even just the term convex lens you use, that will define this type of lens. So this is a very typical lens, and maximum cases, like did you notice when we were studying reflection of light, so concave mirror was getting used a lot more than convex mirror. Here in case of lenses, convex lens get used a lot. And see, if we take a plane mirror, plane reflecting surface and a convex reflecting surface, and somehow we combine both of these, plane reflecting surface and the convex and plane, both of it facing each other, so that becomes plano convex. This is plano convex lens. So plano convex lens. And see, here we combined it facing each other, both of these were facing each other. If one is facing oppositely, so that this becomes concavo convex lens, because one side has this concavity, this part, this is acting as concave, otherwise has convexity, the bulge part. So concavo convex lens. Mostly you will be getting convex lens only. This you should just be aware of what all lenses are present. Then if you combine both the spherical refracting surfaces in opposite manner, in opposite direction in the sense concave surfaces, when both the surfaces are having concavity on both the sides, that becomes double concave lens, you can say biconcave lens, you can say, or simply whenever a concave lens is said, concave lens, we refer to this lens. Class, this concave lens, no, this is known as this concave lens, this is diverging lens. All right. And in the convex lens case, you have the rays converging at a point. At their focus, the rays get converged. And for diverging rays, they just diverge the rays. So how we say image is formed? How do you see images formed? Suppose this has diverged the rays like this. See, you extend it, you produce it and see where the image is formed. So we had a specific name to such kinds of images. Remember? If such kinds of images are there, what do we say? Yes, such images. The lines are actually not. Yes, Jiva.
Virtual.
Virtual. Good, said. Virtual images. See, the lines are because they are not actually intersecting. They are appearing to intersect because you have produced it. See, in case of convex lens, what will happen? Rays will come, it will converge it. So here the rays will actually be meeting. So this will be a real image that has been formed. Here virtual images are formed. And see, again, one plane side with concave part, that is plano concave. Same thing, the way as convex. And if you construct again the opposite part, you will obtain this. So this is common for both concave and convex lens, because in any manner you construct it, you will get concave convex lens, or even you can call it as convexo concave lens. Both names are same. So much details are not required. You should just be aware. Now, one important term is optical center. Optical center becomes the reference point. See, when we had spherical mirrors, only this part was required, because when we had drawn the principal axis across it, this becomes one pole, this becomes another pole, right, for here. But a center should be there. In mirrors, in spherically refracting surfaces, we used to call the center part as pole. But now two poles will be there. Everything will be double. No. See, for this part, you will get the focus here. And for this part, you will get the focus here. Understood? So you will be having two focus. That we'll see. Two foci we'll see. But the central part of the sphere, of the lens, this is known as the optical center. So optical center is a very important landmark. You can say very important reference point. So you should remember, this is for the diverging lens and this is for the converging lens. Basically, these are not thin lens. These are thin lens that have drawn. I mean, they do not have so much aperture that from here you will take a greater distance and here you will take a greater distance. And one more thing, class, when you will draw, see, convex lens, one ray is going and here it is getting refracted, that's it. But do you notice there are two spherically refracting surfaces? One is here. So in reality, how refraction occurs? In reality, first the refraction occurs at this point. Then it moves, then again the refraction occurs at this point. It does not occur like this. Refraction occurs first like this, getting refracted like this. But you will be drawing it like this only. Why? Because these are thin lens. This variation is so small than this variation that we just assume the first part only. Both the variations, this variation is very small, very small. Though in reality, we have two refracting surfaces. So 2 times refraction should occur. No, why 1 time refraction will occur? Two spherically refracting surfaces are there. So 2 times refraction should occur. But drawing every time, this is also difficult, first thing. Secondly, the variation is very difficult. So why not to draw the easier part for the calculations, right? Otherwise, just keep in mind, refractions will occur twice. One from one surface, another from the another surface. Coming to the third topic that I had discussed was, yes, focus. See, this again, this is the first focus, this is the second focus. This you have the first focus, this you have the second focus. But this is known as second principal focus. This first one is known as first principal focus. So which one will be used? Two foci are there. The image will be converged at single point. That depends on the direction of light. If the direction of light is from the left side, it will come here. If direction is from the opposite side, it will converge here. But see, class, for the focus of the convex lens, second principal focus is much important, because usually the light rays are kept on the left hand side direction of it. So this second principal focus becomes important for convex lens. And if you have a concave lens contrary to it, so F2 is this, means on the opposite side you would have F2. This becomes F1 because second principal foci, as I've told you, is important for the lenses. But it is not very specific. Whatever is the direction of light, in the opposite direction, the images will be converged or diverged. So that is not a very important thing to note down, but just what you should remember is this. Two foci are there. Depending upon the direction of incident radiations, images will be formed on either of the focus. And again, same thing. And from infinity, light rays are coming, images will be formed at the focus. Those rules remain the same. Sign conventions remain the same. Sign conventions, which we have studied earlier. We have one very important topic, the lens maker formula, but I think these introductory points, you should write it down. So lens maker formula derivation is very easy. If you have understood yesterday's class, derivation is simple. Copy all these points quickly, then we'll do lens maker formula.
Ma'am?
Yes, Asta, say.
Ma'am, this mirror formulas derivation and lens formula derivation is not there.
Mirror formulas derivation and lens formula derivation. No, they are there in the syllabus.
Yes, ma'am, like our teacher taught 1 by V plus 1 by U is 1 by F.
Yes, we have also done mirrors formula derivation in the class itself. Lens formula we'll do today. Mirrors formula we had done, no, when we were doing reflection. Reflection, it is included in
ma'am.
reflection.
Yes, ma'am. Yes.
Okay. Lens formula is left. That will be done after lens maker formula only.
Okay, ma'am.
Ma'am, can you scroll better? Done, ma'am.
See class, lens maker formula, no, basically this connects refractive indices. This is, let's say this outer part is N1, this is N2, object distance, image distance with the radius of curvatures, fine. We'll see, it was actually the formula for the focus and power also is calculated using this only. Now see, let's say O1 is the object, fine. So rays are going, O1 is the object, so rays are striking this. Let's say this is striking this, so this is O1. Fine. Now, what did I tell you? How to draw the center, how to draw the normal? By dropping the center of, by dropping the line through the center of curvature, that gives you normal to the curved surface. Because this is very difficult, no? How to draw the perpendicular to on a curved surface. So, see, this. So see, normal has been dropped through the center of curvature. So like this, you get the perpendicular to it. Even if you draw it no perfectly using a protractor on your notebook, then you'll be actually able to see this 90-degree also. All right. Now see class, what will happen? Here refraction will occur at this surface. At this point, refraction will occur. So see, because when refraction will occur at this point, so for this point, you will get, if I produce this, what did I say? We get refraction twice. So for lens maker formula, that's why I've drawn a bigger lens. For lens maker formula, we are seeing how the focus is actually built. So see, refraction will be there, somehow it will be. But see, by chance, let us just extend. If the second refracting surface was not there, here the image would have been formed. Let's say this is the temporary image. Now see, once the immediate image or intermediate image, you can say temporary image, you can say intermediate image, this will act as a virtual object now for this spherically refracting surface. So now, because of this second image that has been formed here, this second image, you will get a final image. Let's say final image is somewhere here. This is the final image. So this is how the refraction occurs in a lens. When you draw ray diagrams, for this derivation, you have to draw it like this. But in general, whenever you use, no, we'll also see lens formula also when we'll see, you'll notice that we don't perform these here like this one, this twice. All right, we just simply take the lens. One time refraction, show it like this. But in detail, this is occurring. And why is it getting refracted? Because of this intermediate image. Because of this intermediate image. All right. Now see, from the optical center, we measure all the distances. So O1 is the object. So this becomes the object distance. So these will be the radius of curvatures. Let's say this is R1. This one is R2. This is the final image that is formed, but we will be requiring this as well. That is the intermediate image that has been formed. Now see, derivation is simple. Derivation for this is simple. At one surface, just notice this class. How do you have to solve? Then other steps are just simple simple mathematical extension. See, for the first surface, this radiations that are going, rays are going from air to this glass, right? So this is from rarer to denser. So spherically refracting, if you look half portion of it, this is acting as spherically refracting surfaces from rarer to denser. You have already done this. Second part, now rays are going where? Now rays are going from glass to air, right? So this is from denser to rarer. You have two equations. You just have to simplify both the equations. Understood. So rarer to denser at the surface one, first surface. So rarer to denser surface. So formula will become what? Formula will become N1 by minus U plus N2 by V1 is equal to N2 minus N1 by R1. Why did I write V1? See, object for first surface is O1. An image that is formed is I1. Remember that intermediate image that was formed. So image distance for the intermediate image is V1 only. So this formula is applicable. But see, when you shift from denser to rarer at the second surface, I1, that is the intermediate image that acts as the virtual object, and final image that is formed is I. So now how will we write the formula? How will we modify it? N2 by minus V2. Not V2, sorry, V1. V1 we have taken, no, for the intermediate image as the object. So this becomes minus V1 plus, then it will be N1, because it is from denser to rarer. So this will also be shifted. So N2 by minus V1, N1 by the image distance that is final V is equal to N1 minus N2 and the second radius of curvature R2. This is R1 over here. This is R2 over here. Two equations you have. Now you just need to add both of these equations. That's it. That's what is required in the derivation of it. Rarer to denser at surface 1, denser to rarer at surface 2. So if you add both these equations, add on both the sides. So N1 by minus U plus N2 by V1 plus N2 by minus V1. And it was what? Plus N1 by V. This is equal to adding both the terms that are present on the right hand side. So that becomes N2 by N1 minus N1 by R1 was there. Then N1 minus N2 by R2. This we had. Is anything getting cancelled? Yes, see, these two terms are getting cancelled already. So N1 we can take common from here, right? Here from here we can take N1 common. So this becomes, from here we are left with 1 by V, and from here we are left with 1 by minus U. So minus 1 by U is equal to, let's take N2 minus N1 common. So a negative sign will be left here because this is N1 minus N2. So if we take N2 minus N1 common, from here we'll be left with 1 by R1 minus 1 by R2. Clear till here? Class, we did mirror formula. What was mirror formula? Remember? I think Asta announced it already.
1 by V plus 1 by U.
1 by
V
U.
plus 1.
1 by U. Yes, 1 by F is equal to 1 by V plus 1 by U. We'll be doing today only lens formula if time is permitted. See, lens formula is similar to mirror formula only, but a difference is there that 1 by F becomes equal to 1 by V minus 1 by U. This term, can you relate? Is this 1 by F? Same thing. This is known as lens formula. Lens C class, lens formula is different. Lens maker formula is different. We are deriving lens maker formula. We are not deriving lens formula. And in your question also, in your final exam also, whatever term you get, be sure of it, whatever it is asking, whether it's asking lens maker formula or lens formula. So from this, we just understand and get a hint that yes, that part is 1 by f. It means n1, and here you have 1 by f. Then rest of the terms, n2 by minus n1, 1 by r1 minus 1 by r2. Now we just have to bring this n along the refractive indices side. So that becomes n2 by n1 minus n1 by n1. That's it. Then we are left with 1 by r1 minus 1 by r2. See class, this both of these will get cancelled. So what are we left with? n2 by n1 minus 1 is there. Here we are left with n2 by n1 minus 1, 1 by r1 minus 1 by r2. All right. Now see, this is the final formula. It's better if you write it like this to concise it. 1 by f will be, see, n2 by n1. This we have done, no? N2 by n1. That can be written as n21, refractive index of second with respect to 1, minus 1. This is 1 by r1 minus 1 by r2. So this is the final lens maker formula used to calculate the focal length of a lens when both the refractive indices are given. And why did I write it as n21 and not just n2 by n1? Because we all know n21 we have discussed when we were doing refractive indices only, a refractive index. See class, here also use sign convention every time I'm writing, because many students do not put sign convention when the question is given to them. Whenever you're solving numericals, do put the sign convention and then put the formulas minus plus whatever is given. N21 means refractive index of medium 2 with respect to medium 1. So N21, this term, you can write N21 as N2 by N1 also. So same thing we are writing. All right. And class, one more thing. This is a very, very common mistake that students do. Class, lens maker formula is what you have studied. That is 1 by f is equal to n21 minus 1, 1 by r1 minus 1 by r2. This is lens maker formula. Fine. You have lens formula as well, similar to mirror formula, which is 1 by f is equal to 1 by v minus 1 by u. Pay attention to what is asked, because you have derivations of both of it included in your syllabus. So any can be asked to you. Note it down, then let's practice some numericals on this formula. This formula based numericals are asked, and lens maker formula derivation is also very common here in the questions to be asked. So till here you all have written. And lens maker, this definition definitely is not asked, relation between all these, but just for your remembrance. Note it from here. In any step you get stuck in between, please let me know, because this derivation is important. So it's better if you all mark important also in your notebook. Derivation as well as the formula.
Total magnification will be in this, right?
Yes, there.
Total magnification will be in lens, right?
Yes, magnification. It will be in lens.
Ma'am,
Hmm.
ma'am, intermediate image is basically virtual image, right?
Virtual image that has been formed because of object one. But when the image is now formed, so this is not the final image because yet refraction is left to occur. So instead of the first object, this becomes as the object. So this is what we were studying in the first class, virtual object and images. Like this only, intermediate images somehow act as the virtual objects.
Yes, ma'am.
Ma'am,
Yes, Ahmad.
ma'am, can you just explain these calculations again by adding 1 and 2?
Which one? This add one and
Uh,
two. Okay, yes, yes. See, here, this was the first equation, and here the second. See, we have just added these two sets of equation. Fine, these two. Now, see, if you add, signs won't change, right? Because when you're adding, so in subtraction, no, you just change the sign. So it means n2 by v1 is there and n2 by minus v1, or you can say minus n2 by v1. See, this term and this term, they'll get cancelled, right?
okay.
So same thing is left over here. These two terms get cancelled, rest of the thing is left as it is. Now see, on the left hand side, n1 can be taken common from both of these. So we can write from here, we are left with 1 by b. And from here, we are left with minus 1 by u. So this is it. And on the right hand side, I have taken n2 minus n1 as common. But see, do you see n2 minus n1 here? This is n1 minus n2, no?
Okay.
So if I take n2 minus n1 common, here I have to put a negative sign, then only I can take n2 minus n1 common. So
Okay.
those steps are there. Clear?
Okay. Yes, sir.
Yes, class. See, so you can begin your test of EM waves. All of you have to open up your cameras. Let me just start with the focus mode. So you'll not be able to see each other. Yes. So only host will be able to see you. So I think all the DPs have also gone. All of you have to open up your cameras and start beginning the test. And again, I'm saying all those who will not open up their videos, their papers will not be considered. So you can
Ma'am, should
start.
I also,
Hmm?
ma'am, should I also attempt the test because I just started yesterday? That's why.
Yes, Emma, can you repeat?
Yes, sir. Should I attempt the test or because yesterday I came back, I didn't know about the test. So
Okay, actually this test was of last weekend only.
yeah.
So didn't you prepare for last weekend? Last weekend also you were not there.
Yes, ma'am.
Okay, so see if you are prepared with EM waves, then attempt the test because this is not difficult. And if you think you have not studied EM waves, then it's okay.
Because I have to leave also now, ma'am. Actually, I've informed the management also because of my project. So,
Acha, ठीक है man. Okay then.
okay. I'll just take the copy of the
Mhm.
snare practice.
But then Imad, send me it as an assignment on WhatsApp at least. Okay.
Okay, okay. I'll do it.
So currently, I think only Alan's paper is under consideration. So Alan is attempting the test.
Ma'am,
Anushka.
ma'am, can I have my video off because then the internet it becomes slow and I won't be able to see the screen clearly.
Okay, that is fine. You can do one thing. Take the screenshot of it. Take the screenshot right now when the screen is clear. Then you can switch on the camera because nobody
Yes,
else will be able to see you. Okay,
yes,
if
ma'am.
you're fine with it.
Done. Thank you.
Okay, man. If you've completed, then share it on the group. You're added no on the group, Ahmed. Just share it on the group, then convert it into a PDF and share it on the group.
Okay.
Okay, Ahmed, I've received your paper. You can leave.
Thank you.
Ma'am, did you receive my paper?
Yes, yes, Rosanna, I've received. You can leave now.
Yeah, thank you.
Ma'am. The ma'am.
Yes, yes, Jiva, I have received yours. I was
Okay, ma'am.
okay. You can. Thank you so much, Jiva.
Thank you, ma'am.
Ma'am, ma'am, I've sent my paper in the group. Are you able to
Yes.
see?
This one, last one, Anushka. Yes, Anushka got. I have got yours. So, Asta, you are just submitting your paper now. You have also completed.
Yes, ma'am, only the scanning is left. I'm doing it.
Okay, okay, Asta. Okay, Anushka, you can leave.
Thank you, ma'am. Bye, ma'am.
Ma'am, should we send it in group or personal?
Group. Send it on the group.